Hello. So the next problem we will be doing is number 16, and we have to let e sub n equal to the interval 5 plus 1 over n squared to infinity. So first, we have to find the union, and we start at n equals 1. So we will draw a visual for us from 5 to infinity, and 5 plus 1 over n squared would be 6. 5 plus 1, 6, and the side is just infinity. For this, it'd be 6 to infinity. For e2, we'd get 5 plus 1 over 2 squared, which is 4. So that's like 5 and a quarter. And the other side is still infinity. 5 plus 1, 4, infinity. The next one will be 5 plus 1 over 3 squared, which is 9. So if we can see, this is getting smaller and smaller. So we'll get closer to 5. This side remains to infinity. So we can say that the union will be the union n equals 1 to infinity for e sub n will be 5, not including 5, to infinity. And now for the next step, we will prove our answer. And to prove it, we will need to show that it is a subset this way and a subset that way. So first, the union of n equals 1 e to the n, which is the same as the union n equals 1 infinity of this interval that we work with, is equal, is a subset. We're working on the proof now, so this would be the first one. Actually, yeah, all right, is equal to 5 to infinity. And so our first proof will be a subset in this direction. So we will be starting with this side. Let's let an x exist in the union and equals 1, 5 plus 1 over n squared infinity. And to help us out, we'll write kind of our goal. Our goal will be to show that there's an x here, so that x exists in 5 to infinity, which is equivalent to 5 being less than x, not less than or equal to, because the 5 is not included. And that is about what we want to get to. So from here, if we let x exist in the union, then there exists an n in natural such that x exists in this given interval right here. because in the union it would mean all cases. So we're gonna combine like all these, and if X exists in this last one, it would exist in the union. So we're saying there exists an N such that that is true in N naturals. Hence, the way we move this one down here, we will move this one down as well. And X will be greater than or equal to 5 plus 1 over N squared and less than infinity. But 5 is less than 5 plus 1 over N squared, where N can't be equal 0 in the naturals, because, well, this won't be 0 or less, so we see that, but if we subtract 5 on both sides, we can see that we'll have 0 is less than 1 over N squared. So, therefore, by transitivity, we see that 5 is less than that right there, and we will highlight these because that's what we want to write. 5 is less than, well, we won't highlight that one. 5 is less than X and less than infinity. So X exists in the interval from 5 to infinity, and that is the first part. And for the second part, we will now prove that interval is a subset of the union. So to start off in this direction, here, let me look at the equation, this one up here. I'll rewrite it on the next page.